say I'm just giving you the questions that since you know the two-dimensional matrix, so the thing is that say if you want to compute say 1 1 1, you know 0 1 1 0 0 1, this is the corresponding matrix that you did in class 12, I think so. So you have to compute this value in order of one time. How? That means order of one time means the constant time. You have to compute this in order of one time. That is a programming question. That means you have to compute it in order of n, and since this is you have to compute in order of n, that means you cannot use any loop. তুমি কোনো লুপ ইউজ করতে পারবে না, বিকজ লুপ ইউজ করলে অ্যাটলিস্ট কমপ্লেক্সিটি তুমি দেখছো n এর অর্ডারে বা n by 2 whatever be the thing log n এর অর্ডারে, বাট you have to find it in order of 1. so what you can do, কিভাবে করবে, any hints? Because that type of questions, if that type of questions is given in different competitive exam, that means that cannot be solved by normal process, because you cannot do the matrix, you cannot do it only by using just doing the for loop or something else you have to calculate something. So the thing is that let's see what should be the thing. এই রকম প্রবলেম দিলে আমাদের অ্যাপ্রোচটা এই রকমই হবে, say 1 1 1, that is 0, say 1 1, and say 0 0 1. So now that if this is a, if we multiply it with 1 1 1 0 1 1 0 0 1, if we multiply it with this, then what we will get, that means 1 with this, this with this, and this with this, that row should be multiplied with this column, you will get 1. In the second case, that 1 and 1, that means 2. In the third case, that is 3. This is 0, this is 1, this is 2, this is 0 0 1. So again, if we multiply it, say 1 2 3 0 1 2 0 0 1, if we multiply it 1 1 1 0 1 1 0 0 1, if we multiply it with this, what we will get, we will get say 1 3 6 0 1 3, that is 0 0 1. So the thing is that what we can get from this pattern, that is 0, that is 0, this is 1, this is 0, this is 1, this is 2. That means if we multiply 2 times, here this 2 is come. If we multiply 3 times, there is 3 is comes. And you will see also the same thing, that is 2 and that is 3. That means when you are multiplied 3 times, it will come as 3. And what is 6? You will get, when we multiply initially, that is 1, then 3, then 6. 1 3 6. And if this is nothing but the sum of the natural numbers, that means n into n plus 1 by 2. When the value of n is equals to 1, you will get, we will find 1. When the value of n equals to 2, then you will find 3. When the value of n equals to 3, we will find the value as 6. So what we can say, that 1 1 1 0 1 1 0 0 1, if this is to the power n, then what we can write, this 1 is fixed, this is n, this is n into n plus 1 by 2, this is 0, this is 1, this is n, this is 0, this is 0, and this is 1. So the thing is that you can compute it order of 1, because you just give the value of n, and depending on the value of n, that will be calculated, and if you just print it, your result will come out. That can be done in order of 1. Is it understandable or not? বোঝা গেছে যেটা বললাম?
হ্যাঁ স্যার।
Okay, so that type of problem যদি তোমাদের দেওয়া হয়, that is nothing but you have to, প্রথমেই এই সেম প্রবলেম হয়তো আসবে না, বাট যে চিন্তা করবে তার ওরিয়েন্টেশন যেন তা এরকম হয় যে যখন অর্ডার অফ 1 বলবে তখন আমি এইরকম ভাবে করব বা এইরকম ভাবে অ্যাপ্রোচটার দিকে যাব। বা আগের দিন আমরা যখন অ্যারের প্রবলেমস গুলো করলাম তখন দেখলাম দ্য অ্যাপ্রোচ ইজ ইম্পর্টেন্ট। তুমি যেভাবে ভাবছো সেই ভাবনাটা ইম্পর্টেন্ট। প্রোগ্রাম রাইটিং চেয়েও একটা প্রোগ্রাম দিলে আমার অ্যাপ্রোচটা কিরকম হবে সেই অ্যাপ্রোচটা কিন্তু আমাদের কাছে ওয়ান অফ দ্য ইম্পর্টেন্ট থিং। সো নাও আমরা আগের দিনের যেখানে ছেড়ে এসেছিলাম সেই জায়গাটাকে দেখব। That means I think it is clear what is the difference between function declarations and function definitions. That is called, the functions. That means what are the, differences between, function declaration, declaration and, function definition. Function definition, that means function declarations and function definitions. So function definitions that represent where the complete function body is written. That means what I am saying, that function, these definitions that actually represents where the, complete, where the complete function body is written, where the complete function body is written. And memory is allocated for functions. Memory is allocated, for function. And function declarations or function prototype, that is the meaning of function definitions. And for function, declaration, function declaration, or, if we say about, or function prototype, function prototype, that is nothing but that means giving the reference of the functions. That means, function declaration or function prototype, that means giving the reference, of the function. So through declarations we assure the compiler, assure the compiler that the complete function has been defined somewhere else in the program and will be provided at the time of linking. So what is we did with the, function declarations, that means through, declaration we assure the compiler that the complete function has been defined somewhere, defined somewhere else in the program, else in the program, and that will be provided at the, time of linking, and generally the declaration is written, at the top of the main functions of the actual, and the actual functions definitions that is provided after the main function. That is the general notations actually we can follow. So now say we have to write the factorial functions. That means we have to write the factorial of a program by using function. That means factorial of a number that we have to write, but by using, function. So if we want to do that thing, what we know, we have to find the factorial of a function, that is all well known to you. But if we write this as a by using functions, then what we have to write? We have to write like that. And the thing is that in that particular case, I am using the particular thing that is called type def. That is type def. This is long unsigned, integer L. What does meaning of that? If we use type def, that means that is a very long data type, long unsigned int. If we use type def, then this, when we use this capital L, it is not mandatory that you are always using capital L. You can use any letter that should be capital. It will be better to represent that. If we write L in our program, this L will be replaced by long unsigned int. That means we have not to write long unsigned int several times. It will be better that we are using type def. If we use type def, that means this L, whenever in our program I write L, that means this particular L will be replaced by long unsigned int. That is the concept. And since in factorial program, I already told you when we are dealing with the factorial that is a very large number. That means it is always better to write a big data type for factorial. So if we write a functions, what do you mean by functions? Functions will take something, and after computations or after doing something, it will return something. It may return or may not return. It will may take or may not take. That will be described earlier. But when we are dealing with the factorial program, that means the number that we entered through the keyboard, that should be passing through the function. That means the function will take one argument, and the function will return after doing the factorial. That means it will return this value L, because that is the thing that the functions will return, because within L we want to store the result, because the result will be big. So when we have to store it in a big data type, that will be always be better. So if we say the function's name, this is fact, and say the function will take integer argument, because that is the number that you want to enter. You can write integer n or something else, or you can just write integer, because in function prototype we need not to write the variable name. We have to just define the data type. That means the data type is L. That means that is the return type. That is the return type, because your functions will return the value that is nothing but long unsigned int. So that's why I am not writing long unsigned int several times. I am just writing L. That L means long unsigned int. That's why type def is being used. So I am writing like that before main, and this is nothing but the function prototype. That means previously I am giving a notifications to the compiler that okay, my function's name is factorial, these functions will take integer, and this function will return long unsigned integer, and that is that is function declaration, or you can say function prototype. So now that integer main will come. This is integer main. you know we know we have to take only one variable. Say by using printf, I am just give a number, say, and that will be stored in you know that will be stored in n. So we am writing this, and if we have to just print it like that, I am to print that 5 factorial is equals to say 120. The output should be like that. So that's why I am writing like that, %d factorial sign equals to %long unsigned. So I am writing LU, and in place of %d we are replacing n, in %lu we are replacing the return value of this factorial, like that, and your main program is being completed. That is the simplest program. That means when you have to call this factorial n, it will go to the factorial function, it will compute the thing, and it will return the value of the factorial, and that will be printed in main. And now I have to write the function. That means your function name is factorial. Your function will take one argument, that is integer, and your function will return long unsigned int. So I am just writing L. That is what I am going to write. That is nothing but function definition. That is nothing but function definition. So the thing is, I am writing initially the factorial program. When you write, I am writing the value of f is 1 and the data type of f is L. So I am writing like that. This while this when n is greater than equals to 1, this f should be multiplied with n minus minus. You know that. And I am just writing after completion of the while loop, it will return f. So when it returns f, it will go to that and the function will calculate the thing. So that you know. And there are two things that you have to know. That is, one is formal arguments and one is called actual argument. That is the two terms that you should know. One, you can say the formal arguments and another is actual arguments. So what do you mean by formal arguments and what do you mean by actual argument? That means when a function is defined, it may have some parameter. When a function is defined, in that particular case it has only one parameter, but there may be more than one parameters, and these parameters are useful to receive data from outside, because that I am just calling the functions. That means they will receive the data from outside. So that is the thing you can that means, what do you mean by this formal arguments? That means when a function when a function is, say, defined, it may have some parameters. It may have some parameters, and these parameters are useful. These these parameters are useful to receive data from outside. To receive data from outside. These are called formal arguments. These are called formal arguments. These are called formal arguments. And when the function is called, we should pass you should pass data to the functions. That means when the function is called, what we should do? We should pass data to the function. We should pass data to the function. This data or values, this data or values that represent actual argument. So what is the meaning of that? If we take an example, then we can that means in that particular case, if we just write a simple, I am not writing whole code, I am just writing, we have to I have to write a functions to add two numbers. That means I am passing these two variables, integer x, integer y, that is the the sum, and you just print this value. That means the sum is equals to %d x plus y. Your function will do this task, and say there is a main program, and within main you are writing integer a equals to 5 and b equals to 10, and I am calling the function like that, ab. Here a and b that actually pass the data. You just see, a equals to 5, b equals to 10, you are passing the data. That means actually we are calling sum 5, 10. That means this a and b are actual argument. Here you can say a and b, that is nothing but actual arguments. And when you call the functions, here x and y, that have some parameter, these parameters are useful to receive the data. That means they x and y are receiving the data when you are calling the functions. That is nothing but called the formal argument. That is called formal argument. That's all. If you just know the thing, then that is clear. That means formal arguments represent the parameter in the function definition, and actual arguments represent the data that pass to the function while calling it. That is the main important point that you should remember, that these formal, the formal arguments, represent the parameters, in the function, in the function definitions. That means functions definitions, that is nothing but formal argument, like that. This is nothing but the function definitions. This is nothing but functions definition. In the previous class also you will see this is nothing but a functions definition. That means this particular parameter, that is called formal arguments. And when you are calling the data, that means in that particular case you are just passing the data. In that particular case it has same, but it may have different values. You are taking integer n, and in that particular case you can write integer x. That doesn't matter. If we write the same variable, that also doesn't matter. So the thing is that, but where you should call, that means formal argument that represent the parameter in the function's definitions, and that actual arguments that represent the data passed to the function while calling it. Actual arguments represent the data passed to the functions while calling it. So that is the thing that you should know. Now the next thing that we can talk about, that means that is I'm not thinking for very important, but the thing is in your examinations that will always come. That means parameter passing. That is the thing that is coming in your different examinations. That is nothing but that parameter passing. That is nothing but parameter passing. So there are two methods, that is called pass by value and the pass by reference. The first thing, that is pass by value. That means what in the functions what I am passing. That means this method actually uses in-mode semantics. I am not changes made to the formal parameter do not get transmitted back to the caller. You just remember one thing. I am giving you experience, a program example. The thing is that in that particular case, what we can say, that changes. Yes, the thing is that in that particular case, the changes that made to formal parameter. That means changes that is made to formal parameter do not get transmitted back, do not get transmitted back to the caller. That means who are calling the function. any modifications to the formal parameter, you can say that modification any modification to the formal parameter variable, any modifications to the formal parameter variable inside the called functions or method, inside the called function or method affects only the separate storage locations, affect only the separate storage locations. That means any modifications to the formal parameter variable inside the called functions or method that will affect only the separate storage location and will not reflect it in the actual parameter. তার মানে একটা জায়গায় যদি আমি চেঞ্জ করি তাহলে আরেকটা জায়গায় সেই ভ্যালুটা এফেক্ট করবে না, and that will not reflected that will not reflected in the actual parameter, will not reflected in the actual parameter in the calling environment, in the calling environment. So what I am talking to say, that means in that particular case this method is also known as call by value. This particular method, also known as call by value. So what I am doing here, that means I am just writing a simple program. That means we know that I am writing like that. We are writing a function, say the functions definitions I am writing in that particular case. I am not writing functions, the parameter as a prototype. I am just writing the functions definitions directly. We can write also that, and your functions is nothing but adding this. That means I am writing a plus equals to b, and then I am just printing. That means in function a equals to %d, b is equals to %d, a comma b. So the thing is that I am writing this. So integer main void, so integer x is equals to 5, this y equals to 7. What I am passing the parameter. That means we are just, that's the simple functions that we did. We are just passing the corresponding value, and this 5 and 7 will be passed these functions, and the value a and b will be replaced by 5 and 7. He is doing this, and again it will it will printing the value a and it will print the value b. And in printf, say in main I want to print the value of x is equals to %d, y is equals to %d, this is xy right there, and then return 0. That what is happening here, you just see I am starting from main, the value of x that is 5, the value of y that is 7, and we are calling the functions. That means 5 and 7 has been called. If this is called, that is that particular thing will going to this particular functions, and this particular value is 5 and 7, and we are adding this is means a equals to a plus b. That means 5 plus 7, so the value of a will change and the value of a will change. That means 12. And what it actually prints, what it actually prints. Actually prints the value of a is 12 and the value of b, that is 7. So in functions, the output, if we say in function, it will be printing a equals to 12, b equals to 7, and after completion of this, again it will back to the, it will back to the main function, and it will print the value of x and the value of y. So the thing is, in main, the value of x, that is, it is printing 5, and y, it is printing 7. That means what I am saying, that when you are calling by value, or you are pass the value, that means the a b locations and the x y has different locations in memory. That means if we are doing any modifications to the formal parameter, if there are any modifications to the formal parameter, that will not affect the separate storage locations, and that will not reflect it in the actual parameter, because that is the actual parameter we are calling, the value this, and that will go to the formal. That means that will not affect. That means the value xy storage locations should be different from the storage locations of ab. So what I'm saying, that is the important thing that I want to say. That means languages, if we say that languages, like c, c plus plus, java, that support this type of parameter passing, that support this type of this type of parameter passing. And especially you can say that this java, in fact is strictly, that means c plus plus or c is allowed call by value, that means pass by value or pass by reference, both. But the thing is, java in fact is strictly call by value. In fact, this is strictly call by value. That means it will happening like that. That means if we talk about the shortcomings, of course there are shortcomings, that you have to use different separate memory locations for separate variables. So in efficiency, in storage locations, every programming language has some shortcomings. And of course, if we consider object, that should not be understood by you, but of course সেটা জানার দরকার নেই, আমি জাস্ট লিখে রাখছি, সেটা ভবিষ্যতে এখন বোঝা সম্ভব নয় what do you mean by objects, but at least you know that for object and arrays, copy semantic. If we want to copy, this copy semantics are costly. Costly means we need a different memory location, so that's why that is one of the thing that you think of that. And the thing is that this is called by value concept in your program, in your semester examinations, that will come, that the difference between call by value and call by reference. They will sometimes in WBT they will say you call by address, but that is not the right term. That we call by reference is the better thing to say about that. So then the sixth thing is that pass by reference or aliasing, you can say, that is pass by reference or aliasing, you can say about that. So this technique uses in-out mode semantic, and changes made to the formal parameter do get transmitted back to the caller through parameter passing. There is a thing, that means what we can say, that changes made to formal parameter, changes made to formal parameter do get transmitted, back to the caller, to the caller through parameter passing, through through parameter passing, through parameter passing. Any changes to the formal parameter are reflected in the actual parameter. That means any changes to the formal parameter, any changes to the formal, parameter are reflected, you know, are reflected in the actual parameter, in the actual parameter, in the calling environment, in the, calling environment, environment as formal parameter. As formal parameter that will receive a reference to the actual data, that actually receives a reference. I am giving an example, then it should be clear, but since you have to write in examinations, you should know how to write to the, actual data. That is called, call by reference. So what I am actually talking about, that means, say I am writing the same program in different way. Say so I am writing stdio.h. Say we are swapping two number. What do you mean by swapping? That means A to B and B to A. Swapping means, I think you know that, if this is a 5 and this B is 6, so after the operation that will be 6 and that will be 5. So that is nothing but swapping. We are swapping the number by using parameters. So we are passing, you are just saying pointer I, and I am passing, say, star j, and we are using a temporary variable. And if you use some temporary variable, what you are saying, when I am passing this, that means star I, that means actually I have to pass the address of I. That means, say the address of location is 100 and this address is 200, and say temp has something, say 300. What we have to first to do for swapping, the value of 5 will be stored in temp, then the value of b will be, that is the second step, and in the staff step the value of temp will be placed in b. That is the swapping thing. And since we are writing like that, integer, we are writing temp. So first thing what we have to do, this temp, in temp we have to pass the value from I, that is, if I am writing I and this is nothing but, j. So star of I, that means value of I, that will be stored there. And then second step, the value of j, that should be, that be passed in the I. So I am just writing like that, that value of I, this is star I equals to star j. Star means value at j, that is nothing but 10. So this is the swapping, but this is nothing but the by using pointer. What is the difference of that? If we write, say, integer main, this is corresponding void. So in that particular case, integer, say a equals to 10 and b is equals to, say, 20, and we are swapping, address of A and address of B. We are passing this value. That means when we are writing this, that will not actually in the memory. What I am saying, that this is A and this is B. A is 10, B is 20. Say it has a location 100, it is a location 200. We are calling swapping, address of 100 and address of 200. That will be go. That means when we are calling this ampersand 100 and ampersand 200, it will go to this. And this is the value at 100, star of 100, and this is star of 200. We know the star of 100 is value at 100 and star of 200 is value at 200. That means we are passing the value, that is 5 and 6. That means I am just describing it with respect to, but there is no such, extra variable. That means the memory that is allocated and just passing the address. That means if something will be changed, that will be changed within this location. That means in that previous class, what we will see, this A and B are different and this I and J are different, but here we are passing the address. So that means when you are swapping within the functions, that means actually it will be changing there. That means it will be changing there. That means when you have to use the printf, say printf, I am just want to print A is percent %d and B is percent %d and I want to print AB, you just see the thing, the value of AB will be changing. That means if this is a return 0, that means you just see the value of A, that means we are just passing the address. That means it will change the value corresponding to the address. So it doesn't matter whether we are declaring with the variable A and B. That means internally it will change. So that's why when we have to print the value of A and value of B, you will see the output will be saying A is 20 and B is 10. That means in the previous case, what will happen? You just see in that particular case, when we call the functions, the value of xy it remains 5 and 7. It will not change. The value of only the variable A and the B, A will be changed because we are only modifying the B, A. If we modify B, then it will also change. But in that particular case, you just see that value, that means we are changing the data with corresponding to I and J. But the thing is that actually by using pointer allocations, what we can say, the actual value of the memory is also being changed. And of course that has shortcomings, that many potential scenario can occur. Programs are difficult to understand sometimes. In that particular case, a security concerns is also there. So there are also shortcomings, that many potential scenario. That means there is security issues that may come, that scenarios can occur, and as well as you can say programs are you know difficult difficult to understand sometimes. That is the case actually that is happening. So the thing is that it may be possible that call by value and call by reference, you can do it in a simple program. You can write it in your examinations also. That means call by value and call by reference. That means call by value and call by reference. If we write like that, that means say I am writing this as include stdio.h. That means I am writing this void functions. This is integer a and say integer star b. That means a is passing by value and b is passed by reference. Say a equals to plus equals to 5 and star b plus equals to 5. That means we are just changing the value. That means increment the value 5 for a and as well as for b. So I am just writing the integer main void here, and the thing is integer a equals to 10, say b equals to 20. I am printing this value. That means %d and %d, the value of a and b, and I am calling the function. The function name is func. So I am passing the value a and address of b. I am passing the value a and as well as address of b, and I am again printing the value %d and %d, a and b, and say return 0. So the thing is that what will actually happen if we consider main. So a is a variable say whose value is 10, b is a variable say whose value is 20. Say the address of a is 100, the address of b is 200. So actually what I am calling functions this a variable whose value is 10, and we are passing and %b. What do you mean by %b? We are passing 200. That means the address of b. That means when we are calling the void function, it is from main. That means I am calling from main. when I am calling the void functions, actually the value of a is b10, and that is in some different locations. And value of b, that is 200, and that is also in some different locations. So in that particular case, what I am doing in that particular case, I am just increment the value. That means a is equals to a plus 5, that means 10 plus 5, that is 15, and star b, that is plus equals to 5. So what do you mean by star b? That means value at 200, and that is 20. So this is star b is equals to star b plus 5, that is 200 to 20 plus 5, that is 25. So it will be printing like that. That means we are passing the value and as well as we are calling through reference. So you can do any functions program uh, like that. That means any program you can convert it into a functions. That is not an issue. That is not a big issue if we want to convert the function. So the next is, I am not going details today. We have to take another class. The thing is that is one of the important thing, that is called recursion. That is called recursion. So the thing is that means we are calling the same function several times. That is called the recursions. And of course, that most computer science concepts have their origin in mathematics. So recursion is no exception. So if you can study, if you studied mathematics in class school level, so there you have come across such equations like that summation of n. If we write like that, it can be written like that: n plus summation of n minus 1 if n is greater than 1, or 1 if n is equals to 1. Or I can write same as that. That means that is a summation. That means summation of n can be written as n plus summation of n minus 1 if n is greater than 1, and it is 1 if n equals to 1. Or you can write same way. This means sum n, you can write say n plus sum n minus 1 if n is greater than 1, and it is 1 if n is equals to 1. That is a simple mathematical complex. And this summation is nothing but the summation. That means what I am finding, sum of first n natural n numbers is equals to n plus sum of first n minus 1 numbers. And when n comes 1 becomes 1, the sum 1 has a fixed value 1. That is the case. If we express it, what I am saying, that sum of the first n numbers, the sum of first n numbers, is equal to n plus sum of first n minus 1 numbers. Sum of first n minus 1 numbers. And when this n becomes 1, what we find, this sum 1 has a fixed value 1, has a fixed value 1. So what we know, the sum of first n numbers, that is equals to n plus sum of first n minus 1 numbers. And when the n becomes 1, the sum 1 has a fixed value 1. So in plain words, what we can say, the sum is defined in terms of sum itself. And that is called recursion, nothing but that. That means what I am saying in plain words, what we can say, that sum is defined in terms of sum itself, and that is nothing but, you can say, recursion. That is nothing but recursions. And in computer programming, what we can say, when a function calls itself either directly or indirectly, it is called a recursive function. and the process is nothing but called recursions, and the process that is called recursion. So what I am saying, so in computer programming what we can say, that means when a function that calls itself called itself you know either directly or you know indirectly, it is called a recursive function. It is called a recursive function, and the process and the process is called you know recursion, and the process is called recursion. This is a recursive function, and this is the we are calling this as the recursions. So the function, when the function stops calling, that means every function, if we call the recursion, that should have a terminating conditions. That means here in that case when the value of n is 1, you know that the value will terminate it. That means your functions will terminate it. That means it always has a termination conditions, otherwise that will create a mesh. That means what the recursions actually does, that means what we can say, that recursion is a that is nothing but a problem solving technique. That is nothing but a problem solving technique where solution you know where solution of a larger problem solution of a larger problem is defined in terms of smaller instances smaller instances of itself smaller instances of itself. So what you should notice about the recursions, that is the important points that you have to notice, that is recursion always have a terminating conditions. Recursions, you should remember that always have a terminating conditions. That means it always have to terminate terminating conditions. Like in some functions, what you will see is when the value of n is equals to 1, that this is the corresponding terminating condition. That means that will result some particular fixed value. So that always has a terminating conditions, and of course the recursions that perform some part of the task and it will delegate rest of it to the recursive call. That means first you just perform the additions n with the return value of sum n minus 1. That means sum n minus 1 you are calling the functions, and what the return value of sum n minus 1 you are added the value of sum n minus 1 with n. That means you are doing some task and rest of it you are propagating it to the next functions call. So what I am saying, that recursion, that means this that recursive function that performs some part of tasks and that delegate rest of it to the recursive call So if we write a simple function, that means say I have to write a C functions to compute sum of first n. That is a simple function. That means C, I am writing a C language function. I am not writing the whole program. I am writing the function to compute sum of first n. You have to compute the sum of first n. That means first n positive numbers. So what I am writing, if I am writing like that, integer, this is a sum, positive number, so we are passing in unsigned, say integer n, and I am writing if n equals to 1, it will return 1, else it will return n plus sum n minus 1. That is the thing I can write. But but what is the problem? You can think of that. That is the main thing that you observe if you want to write the recursive functions. Say someone call, say someone call n equals to 0, then what will happen? You just see, when this value of n is equals to 0, this condition will not satisfy, and what it returns 0 plus sum minus 1. Again this value it will call minus 1, so it will return minus 1 plus sum of minus 2. So it will goes, there is, we are not putting any boundaries. So if we like that, that will of course an issue. That means it may go to the infinite loop if you are not putting the value of n as 0. So that means you are just writing this terminating conditions, and you will see, okay, your function will write, behave rightly. That may not be possible, because you should check that, because in that particular case, if you just put in value is 0, then you will find it will goes and goes on, because it will return minus 1, minus 2, minus 3, and number is countable infinite, so it goes on like that. So what you have to do, you have to put another terminating condition. That means if say n equals to 0, you have to return 0. And since it is unsigned, so that means the user will not give any negative value, but the thing is user can give n equals to 0. So you have to understand that you can call the function like that, or in more compact way, you can write like that also. That means some, say integer n, I'm just writing return, if n is equals to 0, it will return 0. Otherwise, if n equals to 1, it will return 1. Otherwise, it will return n plus sum n minus 1. That is the way you can write compact way. That means it will return, if n equals to 0, it will return 0. Otherwise, it will check either n equals to 1 or not. If n equals to 1, it will return 1. If not, then it will call the function n plus sum n minus 1. That is the compact way you can write the functions by using this. So you just remember the two things. That means when there is a choice between simple and of circuit code, that means very complicated code, go for the simpler one, unless the other has performance or memory advantage. মানে যদি কোনো পারফরম্যান্স বা মেমোরি অ্যাডভান্টেজ না থাকে, তাহলে বেশি কমপ্লেক্স কোড লেখার কোনো মানে নেই। সবসময় চয়েস হবে সিম্পল কোডের। দ্যাট ইজ ফর অলসো ইন্টারভিউর ক্ষেত্রেও তাই। That is not rule for just for interview, it is generic. The code that we write is read by many people in the team, so the simpler is the better, if there is no advantages like that in other code. And never miss the terminating conditions, else the functions may fall into infinite recursions. That is the main thing that you should know. That means never miss the terminating conditions, else the functions may fall into infinite loop. You should remember that particular fact. So the thing is, that is just the basic of recursion, just the basic of recursions.